Alright, what's up guys? In this video, we're going to pick up with some differential equations. We're going to be talking about linear first order ordinary differential equation that tries to solve the given ODE using integrating factors. So we're given dy over dx plus tangent of x times y is equal to 1. So this is a linear first order differential equation. So remember the form for a linear first order ODE. It has the form dy over dx plus p of xy is equal to q of x. That's the form. Okay. Now you can solve these using integrating factors. So before you can do anything with a linear first order differential equation, you need to make sure that it's in the correct form. In this case, it obviously is. So let's identify what p of x is. So p of x in this case is just tangent of x. And then q of x in our case is just going to be 1. So remember how you get the integrating factor. So the integrating factor that's going to be mu of x is equal to e raised to the integral of p of x dx. That's how you get your integrating factor. So in our case, mu of x is going to be e raised to the integral of tangent of x dx. So hopefully you remember that the integral of tangent of x is just going to be ln absolute value secant of x plus c. Technically we can drop the plus c because we're trying to get the integrating factor here. And we know that the exponential and logarithmic function are inverses of each other, so it's easy to see here that the integrating factor mu of x is just going to end up being secant of x. So that's our integrating factor. The next step is to multiply both sides of the differential equation by the integrating factor mu of x, which is secant of x. So it's going to be dy over dx multiplied by secant of x plus tangent of x multiplied by secant of x multiplied by y. And then obviously multiplying secant of x by 1 just gives us secant of x, which would be what we'll have on this side. What we'll need to do now is apply the product rule on the left-hand side. And so that's going to be the derivative with respect to x for secant of x times y. And then that's just going to be equal to secant of x. So what I did was, again, apply the product rule on the left-hand side. Okay. So once you've done that, what we need to do is we need to integrate both sides with respect to x. So let's integrate this side. And by the way, you can write it as d over dx secant of x times y is equal to secant of x. Or if you prefer to write it this way, secant of x times y and then put prime is equal to secant of x. That's perfectly fine too. Some people write it a different way. Okay, so let's integrate this side. So we're going to integrate this side over here after we apply the product rule. And then we'll integrate this side with respect to x. Okay, so please with me so far on what I'm doing. So we know that when we take a derivative, when we integrate, it's just undoing it. So this is just going to be secant of x multiplied by y plus c1 is equal to, remember that the integral of secant of x dx, that's going to be ln absolute value tangent of x plus secant of x plus c, or plus c2 in this case. Now we know that C2, or excuse me, C1 minus, or no, I'm sorry, C2 minus C1 is just going to give us C. So 1 C will basically absorb this other constant. So we could effectively just write this as secant of x multiplied by y is equal to ln absolute value tangent of x plus secant of x plus c, because again c2 minus c1 is equal to c. So we'll just have one c that absorb the other one. Now, some people say, well, the antiderivative of secant of x is going to be ln absolute value secant of x plus tangent of x, but keep in mind that addition is commutative, so it doesn't make a difference whether the tangent of x comes first or the secant of x comes first, so it doesn't matter. So if you want to write the antiderivative as ln absolute value secant of x plus tangent of x plus c, that's fine too. I just write it that way. That's the way it's written in my calculus textbook, or the way I remember it. Now the goal here is to solve for y, so we need to divide both sides by secant of x. So this is going to be secant of x multiplied by y is equal to ln absolute value tangent of x plus secant of x plus c. Now I'm going to divide each side by secant of x, and the reason why I'm writing this out is because I want to show you a common mistake that students make with this. They forget that they need to divide the constant by secant of x as well. So they'll divide this side by it. They'll divide ln absolute value tangent of x plus secant of x divided by secant of x, but they won't do it for the constant, and that's where the mistake comes. That's why I wanted to write it down. So as you can see, the secant of x is canceled. Then we'll just get y is equal to, I can write my answer as ln absolute value tangent of x plus secant of x, and I can just write this as cosine of x plus c times cosine of x. And we can say that that's going to be our answer in the solution. So when you solve this differential equation, you can write your answer as y is equal to ln absolute value tangent of x plus secant of x times cosine of x plus c times cosine of x. Or to be a little bit more specific, y of x is equal to ln absolute value tangent of x plus secant of x times cosine of x plus c times cosine of x. That is your solution. So let me circle that for you. And that's how you solve a linear first order differential equation. So if that one was a little bit involved, that's okay. I do have some easier examples on other videos for you to see. All right, so if you have any questions about how I got my answer, I'll be more than happy to explain it even further. All right, guys, I'll see you next time. Y'all take care.